Alright, now I'm super excited today because in today's lesson, what we're going to be talking about is how to solve any equation as long as it's a linear equation. By linear, I mean it has just x in it, not any higher power of x, like x squared or x cubed, just x, or any other letter, like let's say y or a, it doesn't matter, but as long as the exponent on it is 1. Okay, so we're going to solve these equations, and it doesn't matter if it has fractions, it doesn't matter how many brackets it has. The steps are useful in solving any of these equations. So what are the steps, right? So step 1, what you're going to do is check if there are any fractions. Okay, that just means, are there any denominators? Okay, if there are, then what you're going to do is, if there are any, change all, or maybe I should say convert all to a common denominator. Okay, convert all terms to a common denominator. That's what I should say. Okay, so every term should have the same denominator throughout. Okay, that's going to be step 1 here. Okay, so that's only if you see fractions. If you don't worry about it. So if you don't see fractions, move on to step 2. Okay, it's that easy. All right. So what is step 2? Step 2. If you see brackets, apply distributive property. Okay. Oh, also, then cross out. So once you, in step 1, once you convert all to a common denominator, then cross out the denominator. That would be the next step. That'd be pretty important to mention. Then move on to step 2. Okay. If you see brackets, apply distributive property. So we talked about that in the last video. You could do distributive property. Okay. Step 3, move like terms so that they are on the same side. Okay. So the like terms have to be on the same side, then collect like terms. It's that easy. Okay. If you move terms to opposite sides of an equation, you have to change their sign. Okay, that's important. So if you have, let's say, minus 2x on one side and you move it to the opposite side, that's plus 2x. What you're really doing there is you're adding 2x to both sides. You're doing opposite operations the whole time. But for whatever reason, what I find is students respond better to just saying move the term to the other side, provided that you change the sign. So I'm just going to run with that. Okay, step 4, once you move and you collect, then apply opposite operations in order to isolate for your variable. Okay, this is solving. Okay, so as soon as you get, let's say, x equal to a number, you've essentially solved for your variable. And that's the whole point. You're solving the equation. Okay, so that is incredibly important. So what we're going to do is, I'm going to line this up here. Okay, and I'm going to do some examples with you. And these are just random examples. Here we go. So let's see. Example 1. Let's say 2x minus 2x plus 5 equals 3x minus 10. All right, so minus 2x plus 5 equals 3x minus 10, and I have to solve that equation. Well, check if there are any fractions. So I obviously don't see any fractions in example 1, so I can move on to step 2. Do I see any brackets? No brackets at all. So I can move on to step 3. Step 3, it says move like terms so that they are on the same side. Then collect like terms. When you move terms to the opposite side, you have to change their sign. Okay, so here's what I have to do. I need the x terms right here to be on the same side. Right now they are not. They are on opposite sides of the equation. So what do? Well, I can either move 2x over there, but change the sign from a minus to a plus on the opposite side, or I can move 3x over. It doesn't matter. I'll choose to move the 2x over to the right side to make it positive, and I'll get a positive x term on the right side. So we'll see. But if I move 2x over to the right side, guess what? I have to move -10 over to the left side. Okay? That's the choice you have to end up making here. So if I move the 10 over, it becomes +5 + 10 on the left side, because this thing changes to a plus on the opposite side. And then I get 3x + 2x instead of -2x. That sign changes. See how I've changed the signs here? So the sign now to the left of the 2x is not minus anymore, it's plus on the right side, and the sign in front of 10 to its left is a plus, not a minus anymore. So that's the idea. And now all I have to do is collect. So 5 + 10 on the left is 15, and 3 + 2 is 5x. And now the last step in the process, step 4, is apply opposite operations. Okay, now we've done this. Very basic stuff. We've done it. So how do you apply opposite operations here? Well, what you have to do, is that legible? Yeah. Okay, what you have to do is you have to do the opposite operation of what you see in the equation to get x on its own. All right? So here, what I have, okay, is I have 5 times x. How do you undo that? Well, you have to divide both sides by x. That's it. So here we go. Divide both sides by 5. The 5's end up canceling, which is the idea. And x is just going to be 15 divided by 5, which is 3. And that's me solving my first equation. Yay. Okay, now let's do a more complicated example that involves distributive property. It involves fractions. So let's do that. So let's go 3x - 2 over 5 equals, let's see, 1 over 2 x plus 3, okay, plus 10. All right, so that's the equation I give you, and what you have to end up doing is you have to run through the steps. I see fractions and I see brackets, so I have to start right at step 1. Check if there are any fractions. Yes, I definitely have fractions there. I have a 3/5 right here, okay, and I have a 1/2. I have a fraction. Convert all terms to a common denominator, then cross out the denominator. Okay, so every single term has to be converted. This one, this one, this one has to be converted in order to make sure that they have the same common denominator. Here I have a denominator of 1, excuse me. So now I have to convert all of them to have the same common denominator. So the common denominator here in this case is 10. I've got a 5, a 2, and a 1. The denominator is 10. So I multiply that 5 in there by 2 to convert it to 10. But what I do to the bottom, I also have to do to the top, and I only apply it to the first term, okay, to the numerator, the 3. I don't have to apply it to the bracket yet, okay? The moment I apply it to the bracket, that's when I hit distributive property. So anyways, we're still on step 1. So times 5 times 5, and here we're going to multiply by 10, multiply by 10. Okay, so now all I have to do is rewrite all those fractions. So what do I get there? I get, what, 6 over 10 x minus 2. Maybe I should do the bracket in black. That might serve to benefit us in the future. But the fractions that I've modified, I'll leave in red. How's that? And then x plus 3, okay. Plus, and then I've got 100 over 10. So I've converted, and the next step in the process, guys, is to cross out the denominator. Basically what this is I'm multiplying everything by 10, and the denominator goes away. But for convenience, I just say cross out the denominator. Okay, and there you go. Now we've gotten rid of our fraction entirely. So now what's the next step? I'll rewrite this, okay, and we'll apply the next step in the process. 6 bracket x minus 2 equals 5 bracket x plus 3 plus 100. Okay, now here what I'm going to do is I'm going to apply distributive property. That's step 2. Okay, distributive property. 6x minus 12 equals 5x plus 15 plus 100. Okay, now there is an additional step that you can take here. Okay, after applying distributive property, you can actually collect like terms if there are any to collect. So here I've got 100 plus 15. Why not apply that to make life a little easier for yourself? Okay, so you end up getting what? 115 there, 5x. Okay, and it's also important to note, guys, that if you don't see a sign in front of a term, like here, in front of the 5x, then the sign is assumed to be positive. The sign in front of the 6x is assumed to be positive as well. If there is no sign there, the sign is assumed to be positive. Now the next step is to just move terms over the same side. You can move them however way you want, as long as the like terms are on the same side. So I'm going to move 5x over there, and I'm going to move 12 over there. And here's what I end up getting. I end up getting 6x minus 5x equals to positive 115 plus 12. And I end up getting 6 minus 5, which is 1x, or just x, equals to 115 plus 12, which is equal to 127. And there you go. Okay, and as an additional step, what you can do is you can plug in 127 into your original equation, the one that you started with, and check that left side, the value you get on the left side is equal to the value you get on the right side. Now we're not going to do that here. I just wanted to show you how to solve any type of equation that I give you, provided that it's linear, meaning like it only has an exponent of 1. That's nasty. Provided that it only has an exponent of 1, okay, and you know, you can do any sort of question. It has a fraction, a denominator, it has brackets. You just apply these 4 steps and you can solve the equation. There are really simple equations out there. Like you could get an equation like this: x over 5 equals 10. All right, and you have 2 options. I mean, you can do, I see a fraction here, right? So I can do common denominator, or I can just multiply both sides by 5, and that'll cancel at the 5s, and I'll get 50. What I do is I try to keep everything uniform, so I will tell my students to just convert to a common denominator and cancel out the denominator. So the common denominator here is 5, so I multiply the top and bottom by 5, and I end up getting 50 over 5 equals x over 5, and cross out the denominator, x is 50. That's what I kind of do just to keep everything uniform. But you don't have to do that. And certainly in an example as simple as that, you don't have to do any of this stuff, any of the step 1 stuff, any of the step 2 stuff, not even step 3. You just apply opposite operations. So it is what it is. I like to say the world is your oyster. And there you go. Thanks for watching the video. Peace out.